Welcome to our Wednesday night program. I haven't been here for a while. I'm Dr. Diana Hoppe, and I thank all of you for joining me. Tonight, we're in for a really special treat. We have a guest from the Salk Institute. Her name is Katherine Bassil, and I'm going to read her introduction. But before I do, I want to make sure everyone knows who I am and why I'm doing these things. I'm Dr. Diana Hoppe. I'm a board-certified OBGYN here in Encinitas, San Diego, California. And I'm now going to get back into doing my programs, which are Wednesday nights at 6:30 Pacific Standard Time. And it'll be the second and fourth Wednesday of each month. So that's how it's going to be. So tonight we have Kathryn Basel. She is an amazing scientist. She received her master's degrees in neuroscience and was then appointed a PhD student at Maastricht University in the Netherlands. In the second year of her master's, she conducted an internship at the Salk Institute for Biological Studies in La Jolla, which is a really majorly renowned institute for research. That's where she learned the art of brain disease modeling using human-derived stem cells. And we're going to get a little bit into that tonight, but we're going to really focus on stress and how stress affects our brains. Mm-hmm. Kathryn's current project focuses on studying stress susceptibility and resilience in relation to traumatic stress, in order to better understand disorders like PTSD or post-traumatic stress disorder. Welcome so much, Kathryn, to this.
Thank you so much for
I'm
having
so
me.
glad that you're here with us. So why don't we first talk about what is stress? And let's just get everyone to know what is stress and how does it affect our brains. We have a little brain here too that we can talk about. We're going to show some things on the brain.
Okay, so yeah, when we talk about stress, it's mainly what happens in our environment. Some stressful factors that cause us to react, that causes our body to react in certain ways, which gets us in a situation where we need to either, to respond to it. Should we run away from it or should we face the stress?
Right.
So if we want to talk about stress, we talk about also the hormone cortisol. And cortisol is known as the stress hormone. What happens is once a psychological or any physical stress happens to us, our brain, two main centers in the brain, the hypothalamus and the pituitary glands, are in contact with one another. So they are communicating via other hormones and substances. Once the hypothalamus releases a substance to the pituitary then releases another substance which goes to the adrenal cortex, which is it's a gland placed on the top of the kidneys. Mm-hmm. And what happens is that after such a response, cortisol is released. And this release of cortisol will cause several biological changes in our body, which will lead to, those stressful responses where you feel like you are having sweaty palms, your heart starts beating very quickly, you get maybe a bit of a headache, a bit dizzy. So that's your body reacting to stress. And then since today our focus is on the brain, so stress can really harm the brain. It can really, just like the picture shows, it can really strain it, cause a lot of pressure. And this is, of course, through many biological changes that happen. But if you want to talk about stress and its effect on the body in general, it affects almost every part of our body, starting with the hair, our brain, stopping at the hair. You can have hair loss.
Absolutely. Stress can do a lot of things.
Yes. Mouth ulcers, your lymph, it can lead to inflammation. Mm-hmm. So the immune system, it dampens your immune system. It can cause, reproductive organs. So for example, it also can decrease your libido. Digestive tract can make you super hungry, and then this can lead to weight gain. So there is a lot of factors that really play along, but then stress really has an effect not only on our brain, but our entire system, our entire body.
And we know with stress for the reproductive organs, sometimes you can miss your cycle, things can get really stressful, and then your body perceives it. So what are we seeing here? This is an example of...
So we cannot immediately talk about stress being harmful. That's a bit not serving stress nicely. So
because there is some good stress is what you're saying.
Exactly.
All right, got it.
Exactly. Mm-hmm. So the first question we can ask is why do we experience stress as human beings?
Exactly.
And that evolved with time throughout many decades. And that is because we needed a mechanism to kind of face a threat.
Right.
The most basic example is when you see a bear in the middle of the jungle. What happens? How do you react to that? What happens is a response which we call the fight or flight response.
Right.
So your body is either ready to run away from the bear or is ready to fight the bear.
Mm-hmm.
But in that case, we know that, okay, you reason, you cannot fight the bear, so you just instead choose to fly away. So what happens is we have two systems in our body that are contradictory. They are opposite: the sympathetic and the parasympathetic. So the parasympathetic has to do with digestion, for example. It has to do with your immune system. Mm-hmm. So it's things that are going on in your body and you don't really necessarily are very aware of them. The sympathetic is everything else. It's your respiration, it's your heart rate, mm-hmm. it's your sweat glands, it's everything else. So what happens is when someone faces a mild stressor, the sympathetic mechanism is activated. So your heart starts beating very fast, ready to run away. Your respiration increases. You start sweating, and what happens is the opposite, which is the parasympathetic, it starts declining. And what happens is your all the blood in your body doesn't go towards your digestive tract because you don't need it anymore now.
Right.
Now you want to try to find a way to run away.
Right.
So this is mild stressors. Right. And when we are looking at mild stress, we also know that they tell you, it's good if you are before an exam and you're a bit anxious.
That's a good stress.
It's a good stress.
Before we get into any further, let me make sure that everything's going well in the sense of any questions that are being asked by anybody or what's, because so the comments, I want to make sure that everyone's hearing us okay and seeing us okay and that we're enjoying this really amazing program here. So what we're talking about is stress on the brain. And I have Katherine Bassil here with me, and we're focusing on what is the reason we have stress, what's the benefit of it, mm-hmm. and that there can be some good types of stress. Yes. So why don't we go and talk about that a little bit?
So the good types of stress, like I said, it's when you are anxious before an exam.
I think you have a slide on that too, don't you? Here we go. Yeah.
So a normal type of stress is, for example, like the example states, you're going to get a vaccine. You are afraid of the needle. You start also having those same heart palpitations. Your respiratory rate increases.
Kona wants to come on. Hey, Kona. Woo, Kona. There you go. All right, that's my little kitty cat. I think everyone's known Kona. He likes to be in the show too. So anyway, so that could be a little short-term stress, but not bad, right, Kona? Why don't you come over here? All right, so keep going. I'm sorry, Katherine. So he wants to be part of the equation. All right.
That's an example of an exam. Also, you are going to do a presentation in front of a big audience or even a small audience for some people. It can be a bit stressful. But this is good because many studies have shown that mild stress can actually help in leading to resilience for future stressors, because you're already kind of adapted to the stress response that your body goes through. And so future stressors that will come along your way, you will know how to deal with them better.
You're more resilient to them.
Yes,
that's awesome.
Yes,
all right.
Yes.
That's a good thing.
Yeah,
so
it
stress
is a very
can be
good thing.
A beneficial thing in some ways. All right.
And then we talk about not only mild stress, mm-hmm. because this we all have in our daily lives. Even maybe every day we have this a little bit of stress that we go through. But we are here to talk tonight about chronic stress.
Correct. And
chronic stress, which is not tolerable, but it can become really toxic and damaging to both our brain and our entire body.
Mm-hmm.
And when we talk about chronic stress, I honestly think a majority of people are going through chronic stress nowadays, and especially in this modern lifestyle that we are mending. And when you think of, I mean, how can you think of chronic stress?
Well, I can, maybe you want to go back to us being on the screen, or are we always on the screen here? We're on the screen. Oh, okay, cool. Sorry, I guess I'm just still getting used to this whole Be Live. So she's a total whiz at these things than I am. So as many of you know, this year, January, I had my mammogram and I actually got diagnosed with stage 1 breast cancer. And that was from the mammogram, the biopsy, surgeries, etc. And to be honest, I think it was due to chronic stress. And the more and more I put on my plate and the more I was trying to take care of so many things. And also, I think we talked a little bit before we did the show, is talk about the kind of perseverating, kind of always that kind of constant chatter in the brain that's saying, okay, I'm worried about money. I'm worried about this. I'm worried about that. And my mom was going through dementia and she's now in a memory care facility. But that was a constant stress that I didn't know that was affecting my body so negatively. So that's how I see chronic stress is rampant. Absolutely agree with you.
And I think that's what most people take for granted. Sorry. Right. Every day we also talked about that. I can ask you, oh, how are you? And you say, oh, stressed. But this has become such a natural response that people are so immune to it.
It's almost like if you're so stressed, people think it's better. Too. Somehow they're winning if they're more stressed. Yeah. And I think we need to change that mindset, because stress can be beneficial in short spurts, but not when it's toxic, chronic stress.
Definitely. And we can see, right now what damages chronic stress can do to the brain. So when someone is going through chronic stress, the whole stress response system is disrupted. Mm-hmm. Your body is constantly trying to maintain homeostasis, to maintain balance. So even if you go through a mild stressor, minutes, sometimes hours later, everything is back to normal.
Recovers and it goes back.
Exactly. Cortisol levels are back, decreased to normal level. Everything is in balance. However, when you are faced with chronic stress, and we're talking every day, that is really very heavy on your body, on your whole system. Mm-hmm. And what happens is that your body also is not perfect. So it will not be able to maintain this homeostasis. And at some point it will get disrupted and can get disrupted. And one of those effects, harmful effects that we see, is the stressful effect on the brain. So what happens is, after chronic stress, we're talking inadequate sleep, poor nutrition, emotional distress, and we shouldn't look at those as separate things, but they are kind of a chain. They feed on each other.
Exactly.
So after being exposed to such chronic stress for quite some time, you have a massive increase of cortisol, or what's scientifically known as glucocorticoids, in your system, in your brain. And then what happens is this causes, of course, changes to many structures in your body and in your brain, but particularly the hippocampus.
Right. The hippocampus is in the brain, and it's certainly
So the hippocampus, I think you won't see it here, but it's normally in the temporal lobe. So it's in this section. So over the ear.
Right. And that's in charge of memory.
Yes. Right? It's the central most important center of memory, where memory is stored. And what happens is this increase in cortisol leads to those changes in the hippocampus, which leads to decrease in learning abilities, decrease in short-term memory abilities, decrease in attention, perception, the list goes on. Right. And after those changes in the hippocampus take place, the body or the brain is not able anymore to regulate cortisol. And so the cortisol effects are kind of persistent.
Right.
And so you see more and more damage with time. So you might think, oh, this is, I'm stressed today, tomorrow I'm okay, right? My brain will just react to it and will solve everything. But what's happening is that the damage is going to become very heavy over time, and sometimes even irreversible.
So you're saying, just to make sure I understand here, this is pretty phenomenal what you're saying, is that under chronic stress, our brains may get to the point where we cannot get rid of the cortisol, like we can't metabolize it, or what's happening to the cortisol? They're elevated.
So yeah,
and they're causing changes to our brain, and our brain can't resume normal function, literally.
Yeah. So what happens is that when you have stress, cortisol is released in your body. There is a certain amount of cortisol that is released. That's we're talking normal state.
A response.
What happens is that your body is able to degrade it, get rid of
metabolize it,
and this is through a feedback loop system.
Right.
So what happens is certain amount of cortisol is released, then this targets or triggers the brain to stop releasing, because
the ACTH, right?
Exactly, to stop having this cycle anymore, so it inhibits it, and then you have a decrease of release of cortisol, and that's how homeostasis is maintained. But then when we're talking chronic stress, this feedback inhibition or this negative feedback is disrupted because you have so much cortisol that the system is not being able to respond properly. And so a surge of cortisol is there. It will get degraded eventually, but not so damage has been done. Right?
Got it.
Yeah.
Wow.
Yeah.
So let's talk a little bit further. So what happens in the brain long term with stress?
So we talked about the hippocampus, but we can also talk about the cortex.
Right.
So when we talk about the cortex, and the cortex is the prefrontal cortex, it's this frontal part of our brain, and it's one of its primary functions is making decisions. Decision making. And what happens is, just like hippocampal changes are done, the same cortisol also has effect on the cortex. And what happens is that we see a decrease or a lot of death. So a decrease in the number of neurons in that area.
Wow.
And as a result, for example, fMRI studies,
functional MRIs,
have shown that the cortex of people that, for example, suffer from depression is smaller than those that, for example, do not suffer from depression. And that is as a result of this chronic stress. I mean, at least this is what we think is the cause of it. And another very important center in the brain is it's known as the fear center. And the fear center is the amygdala. And the amygdala also has been shown to not decrease in size, but to increase in size.
It makes us more reactive to things.
Much more reactive, much more emotional.
That's why when you're stressed out, you're going to have no reserve.
More anxious.
You're more irritable.
Yeah.
Wow.
So yeah.
That makes sense. That's pretty cool.
Yeah.
Okay.
And what we want to keep in mind, we are now talking about separate structures, but everything is connected.
Oh my gosh, yes.
If you have less, so an atrophy, so a shrinkage of your prefrontal cortex, you will have less inhibition of your amygdala because they communicate with one another, and the same goes on for every other structure. So one.
So there's an interaction, and the amygdala being like the one for emotion, that's going to pretty much take over, and that's when you wonder why your brain function is not as sharp, and you're more irritable and just that's pretty cool. So let's see what happens. I think you're also doing studies with nerves and what specifically chronic stress does to. So let's explain this slide to us and what you're seeing.
So
because this is really cool.
So we are talking now at a macro scale level, right? We're talking the brain, the big structures, the shrinking. But the kind of study that I do, and this is more fundamental, we look into the neurons and the cells that make up your brain. So how do we also find out that stress is affecting the neurons themselves? So we're talking
like really microscopic.
Really microscopic.
Okay.
What you see in front of you here is neurons, 2 neurons. And those extensions are the branches, what we call neurites. And this is how the neurons communicate with one another. So this dot in black is the cell body. This is where the nucleus is, where the DNA of the cell is, and everything else is the branches.
So there's dendrites, and then there's axons, right?
Yes. So the axon is just this very long projection that you see,
Okay.
and the rest are the neurites, the branches that extend from
Got
the
it. Okay.
axon. And what happens is that that's how the neurons communicate. Now, what could you tell me? The first thing that you see between the two states, stress and no stress?
Well, you can see with the stress, you have less lengthening of the actual dendrite, right? And then you also see less of the dendrites, actually like the density.
Yeah.
So you see less communication between the cells, which is something that you need in order to function.
Exactly. So you just stated the two most obvious things. No, and this is exactly what is happening. A shrinkage in the total length of the neuron, but also a shrinkage in the dendrites or the neurites, but also less of them. So you are seeing a decrease in number of those projections. And what's happening is now there is more difficulty of communication between one neuron and the other millions of neurons connected to it. So this is just at the microscopic level what's happening when stress is
So this is amazing to me that just sees so definitively how stress, and this was in vivo, or this was in vitro, correct? In the
This is
in
in
dish?
vitro. This we do in a dish.
In a
So
dish.
you culture neurons in a dish.
Human neurons.
Nowadays you can culture
which is
human
pretty cool. And then
neurons.
and what kind of stress are you subjecting them to?
So you just subject them to the hormone itself.
To cortisol.
To cortisol.
I got it.
Yeah.
Okay. Got it. Interesting. Wow. That's amazing research that you're doing.
And there's a lot of research also on laboratory animals, and what they do is they subject the animal to some kind of stressor.
Like it could be a buzz, it could be electronic shock,
Yeah.
different things. And they've also found that in animal studies, exactly what you've been talking about.
Yeah.
The brain changes in the hippocampus, the amygdala, et cetera. So this is really, so basically we're saying stress chronically at that level that's toxic is going to cause those brain changes in our cells.
Yeah.
Literally.
Yeah.
Wow. Okay, let's see what your next one is. Wow, that was pretty major. That was a great slide. Oh my gosh.
I think
so. What are some things we can do now that we're kind of like, oh my God, we know we're stressed and we want to decrease our stress, because it's really important to have a balance. I mean, literally, I know it sounds so cliche, but we need to have stress reduction techniques so that we can actually decrease our level of stress, because we're just talking about the brain, and we know with the body, there's so many other organs that are affected by stress. Diabetes, hypertension, et cetera. So let's focus on what you've mentioned here. What are some things we can do?
So I think we see these on a daily basis. People telling us, doctors like
I say, yes,
saying, have good sleep, eat a healthy diet. It's everyone tells it to us, but are we really doing it?
Correct.
And I think once, like today, we see what are the really consequences of stress, and taking it lightly can really
cause severe effects.
Very severe effects. And what I think is very nice is that those are easy things to do.
Easy, but we have to do them. And that's where I think a lot of times we say, oh, we don't need to really meditate, or I don't know how to meditate, and I get enough sleep. But sleep is huge in the sense of memory too. I just went to a seminar and that was amazing. What about cold showers? Talk about that a little bit, because you don't normally hear someone say, well, take a cold shower.
So that's interesting. I think this would be the most interesting tip to combat or to avoid stress effects. So cold showers, a very recent study has shown that bathing in cold rivers outdoors has been shown to actually alleviate depressive mood with time. And it at first you would say,
who wants
cold showers, they will actually probably cause more stress.
Exactly.
And more irritation than relaxation. But what's interesting is that cold showers lead to something called cross-adaptation.
So
what happens is that it is true. When you are having a cold shower, your stress response is actually becoming active. And it is releasing cortisol, but mildly. So what this does is that it kind of adapts your body, your system, your stress response to learn how to manage the stress the next time it comes
Wow. So how long were they taking the cold showers for?
I think it was a couple of times a week.
And for how long?
Yeah,
duration?
across a couple of months also.
Yeah,
so
like
it
a
wasn't
10-minute cold
like
shower.
a year.
Like,
It was just a swim in a cold.
okay, got
swim
it.
in a
So
cold
swim.
river.
Okay, wow.
But I think we could start at home, right?
Right, that's
I
what I'm
mean-
saying. Like, what would you recommend? I mean, I know that not everyone wants to take cold showers, but it sounds like that actually might help us adapt better to some of the stressors. It sounds kind of crazy, but what would you recommend then for us to do at home?
I mean, I'm not a doctor or
No, I am, but just in general.
What I would think, and I would probably do it myself. So cortisol fluctuates throughout the day.
Correct.
In our system naturally, and our highest peak is in the morning.
Right.
The minute we wake up, because we need it to be alert and awake,
Right.
cortisol is just the highest, and then throughout the day it decreases bit by bit. I would suggest to take the cold showers in the morning when your cortisol peaks are at their highest, and then you can kind of have this boost, right?
Okay.
So that you don't kind of disrupt its natural rhythm throughout
Right.
the day, because in a way this will cause you also a lot of stress. So I would just probably say, yeah, cold showers in the morning. It will help you to be awake and start your day.
All righty. Well, I think what I do is I go to the steam, and in the steam room they do have a cold shower. So I go steam and then I do the cold shower, but not for that long. But I'll do it for
2 minutes.
2 minutes of a cold shower. All right. Well, that is awesome. Why don't we talk about what you're doing now and the amazing research that you have going on now?
So I think what's amazing nowadays is a technology known as stem cell technology. And
Stem cells. We're hearing a lot about stem cells in the news
yes,
and everything.
Yes,
Yeah.
it is being used for a variety of purposes in science, and it has really been it was a complete it was amazing work that was found out. And what you can do with that is really a variety of things. So what we do is, let's say we want to study depression, or we want to learn more about depression. What happens is that a skin biopsy, a piece of skin is taken from a patient suffering from depression. And what we can do is that with this amazing stem cell technology is we can turn those skin cells or fibroblasts back into their original stem cell state. And a stem cell can give rise to so many different types of cells in your body, including neurons.
Wow.
And what we do is that we then transfer those stem cells or transform them using a bunch of molecules, and it's like a magic potion.
Exactly.
And we just transform those stem cells into neurons in a dish, which we can study, look into, just like I showed you before, differences in dendrite length, effects of cortisol, effects of stress.
Wow.
But other practices which are even more translational to the bedside, to the clinic, where they can benefit doctors like yourself, is they can be also used to test drugs. So nowadays, people that are
that's a little stress right there. Okay.
So people that are diagnosed with depression are immediately given antidepressants.
Correct.
But there is a majority of those that are taking antidepressants are not responsive. And so they are...
Or have side effects and they can't tolerate them, or different reasons.
Exactly. So imagine how amazing it would be if you can take this patient's cells and test those different drugs and see...
Oh, very interesting.
Which one,
if they'd be responsive to
which one is the best responsive, it gives the best the effect. So this is one other route. And another route is cell replacement therapy. And this goes more for neurodegenerative diseases
like Parkinson's or Alzheimer's.
Exactly. And what happens is that they are now looking into trying to use stem cells, or at least neural progenitors. So they are like stem cells, but of very specific types, like the neurons. And what happens is that they would like to inject them in places where an extreme loss of cells or neurons has taken place.
Wow, that's pretty amazing research that you're doing. I mean, and I met Katherine. She came as a patient to me, and I was talking to her, and we just got in this amazing conversation about neuroplasticity and the brain and stress. And it was just like, oh my gosh, there's so much here. We can even do more and more, really.
Definitely, yeah.
And hopefully maybe we will be able to do that. But I know we're going to be closing here because I always like to finish on time. What could you give any closing sentence to those listening about what your research is or what you do with stress in the brain?
I think I would first start with like a piece of advice.
Yes. Advice is always good.
Yeah. Do not take stress lightly. It's not something that you should be experiencing every day. It's not something that is trendy, or
Right.
it's something that you should take very seriously. And those tips that we gave recently is that take them seriously. You don't find meditation. You cannot relate with meditation. Find something that you relate to, that
right.
works for you.
Absolutely.
What else? I think science is really now advancing rapidly in terms of cures or understanding of
right.
disorders like depression and PTSD. But I mean, don't let it get to that point, right?
Right.
We are there to help, and we are there to try to find those answers to so many questions. But people should also, not want to get to that point.
Stressed, right? And there are things we can do to decrease stress.
Exactly.
So I think that's a great point, and it gives us more empowerment that we can take somewhat a control over our lives and decrease the stressors that we have in our lives.
Yeah.
So with that, I'm going to close. I really want to thank everyone for listening and taking the time to be with us tonight. I had special guest Katherine Bassil, and she is getting her PhD and working at the Salk Institute here in La Jolla. So I'll see you next time. It's going to be the fourth Wednesday here in October. We'll be back with another guest, and I hope to have Katherine back again, and then we can talk further about this incredible research. All right. Thanks, everybody, and thank you, Katherine,
thank you
so much.
Thanks. Someone asked a question here.
I didn't see it.
Hot bath. Someone said hot